All right, we're going to jump into our triangle proofs here, using all the same things from the previous lesson. You know, your side, 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 your angle, side, angle, and so on there. All right, so complete the proof. So here's how I usually attack these. I usually go and look at the triangle itself. I go mark everything that is given to me, and then I determine why the two triangles are congruent. Then I go and fill in the reasons. So look here, given AB is congruent to CB, so I'm going to go and find that, and that's already marked for me. So you got one tick there, and then CB, you got one tick there. All right, notice here they also tell us D is the midpoint of AC. If D is the midpoint of AC, I then therefore know that you have these two sides here, these two little small pieces, those are going to be congruent to one another. All right, then like yesterday, we were talking about your shared sides, and you can always assume your shared sides will be congruent. So right then and there, you have three pieces. Therefore, these triangles are congruent by side, side, side. All right, so I'm going to go and start filling all that stuff in to our proofs here. So first thing they tell us, AB is congruent to CB. We know that because that is given to us. Okay, they told us that. D is the midpoint of AC. That is another given thing to us. All right, now this is the part that we marked here. Since D was the midpoint, we marked those two segments congruent. So they're saying AD is congruent to CD. We can say that's because of the definition of what a midpoint is. So definition of midpoint is what we'll write. Okay, you also have the shared side going on here at the middle. So notice here you have BD is congruent to BD. This is that reflexive property I've talked about a couple of times. This is where we actually use the reflexive property quite a bit in this unit here. Reflexive property. Usually this means here you're talking to about your shared side. There you go. And then based off of all that, we said, well, then the triangles are congruent by side, side, side. So you can usually I just have my students write side, side, side. Some of your teachers might do like side, 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 triangle congruence or something kind of like that there. So just make sure you refer to your teacher and ask them what they're looking for on that. Now, once again, you can identify each of the spots here. There's one of the sides there being congruent. AD is congruent to CD. There's another side, and then you had your shared sides. So if that kind of helps you keep everything organized there, that's what you need to do there. You know, keeps it all nice and good. Okay, notice here that they gave us that a bunch of lines are going to be parallel, and then they gave us a congruent side. So there's actually a ton of given stuff here. So since there's a lot of different ways you can go from this, I'm just going to look down at the different statements and then maybe go and mark those, and then we can determine why the triangles are congruent at the end. So notice here that you have W, what is that, WU, where is that? W's parallel. Okay, so that's this little mark in here. These two segments here are going to be parallel to one another. So that was given to us. Now we got to think back to the last unit here. Now we're going to say basically angle WX is congruent to VYZ. So that basically means these two angles right here. Now this might look familiar to you guys. I'm not sure here. Notice you got two parallel lines, and then you got a transversal, and those would be technically corresponding angles. Since you have parallel lines, and you got two corresponding angles that are touching those parallel lines, those two angles are congruent. All right, and that's kind of what we did from last unit. So we're going to put the if the lines are parallel, then the corresponding angles are congruent. All right, and some of your teachers might accept the corresponding angle theorem. So just once again, refer back to what your teacher wants to see there in that case. So anyways, we have two angles marked congruent. Notice that you have another set of sides marked parallel. And this is kind of the same thing. Look at the angles that they're talking about. They're talking about UX, and then where are we? UXW, so that would be this angle right here. And then they also have VZY. So that's that angle right there. So notice those are congruent. And if you draw the same thing here, you got corresponding angles happening right there. If you draw all your lines out kind of like that. So I'm going to put the same exact thing here. If the lines are parallel, then corresponding angles are congruent again. And I actually forgot to fill in that step before that. Hopefully you recognize that this second thing here was one of our second given statements right here. That would be right there. So it's also given. Okay, and then they also, they also told us one more thing here. They told us that the two sides right here, WX, is congruent to YZ. So that was another given thing. So notice here, so far we have an angle, we have another angle congruent, and then we have a side. Now, just because we talked about it in that order doesn't necessarily mean it's angle, angle, side. So we need to go look at our picture here and notice that the side is actually in between the two angles. So this one is angle, side, angle. Therefore, those triangles are congruent right there. And that is it on that proof right there. We are done. So this is the first time we've seen the parallel lines creep its head in to our proofs. So usually if you got parallel lines, look out for things like corresponding angles. Look out for alternate interior angles. Sometimes you'll see alternate exterior, not as much. So yeah, take a look for those right there. That might help us with the rest of our proofs. So let's see what's going on with this one here. A bunch of given things here. I guess AC is congruent to EC. That's already marked for us. So that's nice. Next thing is AB is perpendicular to BD. So that means you have a right angle there. And you also have ED is perpendicular to BD. So you have another right angle. All right, then you also know AC is the bisector of BD. So notice that is a segment bisector. So if you have a segment bisector, that means that these two pieces of your segment are going to be congruent right there. So that right there, it kind of looks like SSA, but remember it's a right triangle, so this is a specific case of SSA. So this is hypotenuse leg right there. That's the only case of SSA that works. So there we go. We got all that. First thing, they actually put all the given stuff in one line. That's perfectly fine. They also said AC is a bisector of BD. I guess that's another given thing. I guess they ran out of room. Angle B and angle D are right angles. I would put, for that one, I put definition of, and not of right angles, but definition of this symbol right here. They told us that they are perpendicular. So I'd say definition of perpendicular lines or perpendicular segments, something along the lines of that. Therefore, after that, we say, well, no, not after that. We also said BC is congruent to CD, and that's this spot right here. We knew that because of the segment bisector. So we'll say definition of segment bisector. Usually it's a little bit better to talk about this step right here. I guess the segments being bisected. Usually it's a better idea to talk about it right after step 2. So maybe the better place for that would be in between step 2 and 3. But you know, sometimes people do them in different orders there. So let's see here. So far we have one of the sides. We have that the right angles are going on right there. So that's kind of like that's like, you know, another side there. And then what else do we have here? Or actually, no. Sorry, angle, and then there's another side. But remember, this is a specific case of side angles, hypotenuse leg, triangle congruence right there. So anyways, be kind of careful there on that. That's kind of a tricky one there. The trickiest part is using HL instead of doing side angles. So, all right, write a proof. Here we go. Given, and it looks like all this stuff's already marked for us. JN. Oh well, I guess none of the things are marked here. So I guess JN. I'm assuming this is JN, and then KN. Yep, so N's got to be there in the middle. Those are congruent. And then I think you also have, oh, I'm sorry, I'm reading this wrong here. First, you have JN and then LN. So I should probably have, where are we? Oh, LN right here. So JN, LN. Sorry, that's a little confusing when it's not marked already for us. And then you also have KN. And then M. And I notice here too, I'm looking here at the triangle, so notice it's JKN, so that you got all the stuff in the right places. And then you also have LMN. So anyways, the first thing here, I guess we're going to fill out a little bit here to the left. So those segments were congruent. That was given to us. Kn was also congruent to Mn. That was also given to us. Angle 1 and angle 2, those are congruent to one another. Remember, that's like one of those things that you can always go mark yourself. Those are vertical angles. So vertical angle theorem in that case. And then you got JKN is congruent to LMN. And notice that those go in the correct order, so that's good. And that would be because of, let's see, side, angle, side, side, angle, side, right there. So just double check, make sure you can do them in the correct order there. And then that is all you need to do on that one. So you have to write out the vertical angle theorem. Make sure you do that. Okay, let's see what's going on here with this one. Write a proof. BE, this is already marked for us, is congruent to BC. And then angle A is congruent to angle D. All right, and then prove that the triangles are congruent. So they actually didn't write out all of the statements here. So what I'm looking here at is, notice here you got some congruent angles going on there because those are vertical. And then once you have that, you got angles, angle, side, and then, angle, angle, side going on right there. And you remember, you can write that as side, angle, angle if you want there. So I'm trying to figure out here, I guess we got 3 pieces, and then you got to talk about the vertical angles. Yeah, so I think both of your given steps here should be in the same thing here. So we're going to do BE is congruent to BC, and then also angle A is congruent to angle D. I guess we'll see if this is enough here. But those were the things that were given to us, so I'll write given. I guess after that we talked about the vertical angles. Now be careful, don't say angle B is congruent to angle B, because first of all, half of you guys are going to write that as reflexive, which technically if you wrote that, that is reflexive. But we want to be specific when we're talking about vertical angles, and I don't know which triangle you're talking about at first here. So I want you to say the angle ABE is congruent to the angle, and I guess DBC. All right, and that's your vertical angle theorem. So be careful there on that one. On that step, do not write angle B is congruent to angle B. You might even want to write yourself a note off to the side. Do not put angle B equals angle B there. Okay, after that, I guess we can go and prove that the triangles are congruent, because that's all 3 of the pieces there that we need. So we'll say triangle ABE is congruent to triangle DBC. All right, and you would say angle, angle, side, congruence, or something along the lines of that, whatever your teacher wants there. So I guess both of the given steps there, I guess they intended it for to be 2 blocks right there. Usually your teacher will let you know beforehand. Okay. Now the second part of this here, doing the proofs, I'm not sure what order your teacher's doing this in, or if you're splitting this over 2 days, but we're going to jump into it here. This thing here is CPCTC. All right, so that's kind of a weird acronym here, and it should be somewhere down here. Once triangles have been proven congruent, you can then be confident that all of the corresponding parts of the 2 triangles are congruent. These corresponding parts can then be used to prove other parts of congruence, such as angles, parallel lines, angle bisectors, segment bisectors, or even other triangles. In proofs, the statement, and here it is, highlight this or underline this, corresponding parts of congruent triangles are congruent. That's what we're using this CPCTC for. So I don't have to write that out a bunch of times. That can be abbreviated CPCTC. All right, CPCTC almost always follows one of the postulates or theorems that proves 2 triangles are congruent. So for example, if I put, the 2 triangles are congruent because of angle, angle, side, like this previous example, then I can talk about the leftover stuff being congruent because of the CPCTC thing, or the corresponding parts of congruent triangles are congruent. All right, so that's essentially what that means. Assume you're trying to prove that a given pair of sides or angles to be congruent in the figures below. What would you have to prove first? So name the postulate. So essentially what we're going to do here is we're going to figure out, okay, why are these triangles congruent? We'll write that down, and then afterwards we can say that the leftover stuff is congruent because of CPCTC. And actually, I kind of wish they would swap this around here. We're going to put the why they're congruent here first, and then the leftover stuff will be congruent afterwards. So let me talk about what I mean here. So notice here you have right angles being congruent, you have a shared side. So you have side angle side going on here. Be careful, it's not hypotenuse leg because you don't have your hypotenuse marked at all. So this is actually side angle side. And then because of that, then we can therefore say afterwards BC is congruent to AD because of the CPCTC stuff. The leftover. This basically means, this is what I've told my students, this is like the leftover stuff of the triangle. The leftovers are congruent. All right, and that's that part right there. So not really sure why they're putting that up there. So determine if they're congruent, and then you can say afterwards the leftover stuff are congruent here. So in this case here, based off of what's marked, you have angle side in this case. Whoops. And then based off of that, then you can say the leftover stuff is congruent. So TSU, this angle over here, is congruent to this angle VSU. All right, and that's because of the CPCTC after that. The leftover stuff. Okay, let's see what's going on here. Looks like you got a shared side going on. So side, side, side. Therefore, after you prove that you have the side, side, side stuff is congruent, then you can go and say that the angles are congruent, and that's because of the CPCTC again. Okay, what is it? Angle ADB, that would be that angle right there. And then CBD, that would be that angle. So leftover stuff's congruent. That's basically the bottom line there. Leftover stuff's congruent. So let's see how it looks here. I think this next one here, we're going to do this here in a proof. So let's see what's going on here. They give us that YX is congruent to WX. So, yep, that is marked. We also are given that, what we have, XZ bisects. This is supposed to say here the angle, YXW. So this line right here bisects that big giant angle. So we know the little two angles that result of it are congruent. And then also, looks like here, I believe this is a triangle here that we're dealing with. So it looks like you're going to have the shared side going on right here. Let's go and look at the triangles they're talking about. Sometimes it's kind of hard to follow what triangle they're talking about when they have a bunch of them drawn. So I go and look at the, down at the proof here. It's talking about YXZ. Yep, so that's YXZ. That's that big giant triangle. And then I guess we're going to say WXZ right there. So that'd be that next triangle there. So they're two giant triangles right there. Notice you got the shared side in the middle. And then afterwards, I guess we're going to prove that the sides are congruent, the leftover sides. So let's go ahead and walk through this here. The first thing here, I think they gave us that, so that's given. Second thing, given, because you have an angle bisector. It's supposed to be an angle sign. Not sure what happened there. Typo. Sometimes Word doesn't like our symbols. Notice that the angles, the little angles, you have YXZ is congruent to WXZ. All right, and that's because you have the angle bisector. So if you have an angle bisector and then you have two congruent angles, you just put that's the definition of angle bisector. Okay, we also have this shared side here in the middle. XZ is congruent to XZ. So we already kind of talked about that. We say the reflexive when that happens. And then therefore the triangles are congruent because it's side, angle, side. If you don't trust me, here you go. Side, angle, side, and then side, angle, side. Once we say that, then we can go and say all the leftover stuff. So this one here is talking about YZ. So there's that other side. YZ is congruent to the side WZ right there. And that's because of the leftover stuff. So we write CPCT, whoops, C for that. So CPCTC, that is written for when the leftovers are congruent. So just one additional step that we're adding on, and that's it. Okay, let's look here at this next one. I think we got, what, 3? Yep, 3 more here. So let's see what's going on with this one. I guess we're going to prove that the triangles are congruent because of HL. Kind of looking ahead here. Given that ST is congruent to VU, I think they gave us here another thing here, because they gave us something about the right angles here. So I guess there needs to be a step added somewhere, something about the right angles, but I guess they forgot that. Not a big deal though. All right, anyway, so the given thing, I guess we'll write that ST is congruent to VU. Oops. And then you got the reflexive property going on here. They're probably talking about the shared side if they're doing that. So I'm going to say TV is congruent to TV. All right, and then therefore the triangles are congruent. Now be careful in the order here. I'm going to start out with STV. So I went STV. So then I need to start out with an UVT. Triangle UVT. Because the hypotenuse, like, remember, they probably need they're missing a step technically here. You need to say something about they gave us that the angles are right angles. So I would probably just add that in, slip it in, between 1 and 2 or something like that. All right. Therefore, once we know all that, then we can say the leftover angles. So let me kind of erase a little bit of this. SVT, that angle right there is congruent to UTV. Okay, so that is because of the leftover stuff. CPCTC. There you go. Okay, last one here. Let's see what's going on here with this one. We're trying to prove that MO is congruent to NO. So let's see what they gave us. They gave us MP is congruent to NP. That's already marked. Also, MN is perpendicular to OP. So we automatically know we got right angles. We also know we have a shared side. You have two sides of a right triangle right there. You have the hypotenuse, and then you have one of the legs. So that's going to be HL for this one here. Okay, let's go fill out everything they gave us here. So, what did they say? MP is congruent to NP. That was given. MN was perpendicular. That was also given. Since that happens, I think they're missing another step here. I think they need to say something about the angles being right angles, and then the right angles are always congruent. So I've seen some teachers put that in, like angle MOP is congruent to angle, NOP. All right, and then say something about, definition, all right angles congruent and that stuff. If you're in pre-AP, they add a lot more steps there that you need to get to look out for. So anyways, you also have OP is congruent to OP. That'd be reflexive. All right, therefore the triangles are congruent because of HL, and then after that, well, then your leftover stuff here will be congruent. So we can say MO is congruent to NO. And that is the leftover stuff. So CPCTC. And then there you go. That is it.